Okay, I think we'll get started. Um, I hope everyone had a great spring break. Um, we're back. Um, as my professor said this morning, spring break has kind of a purging effect similar to final exams. So I'm going to spend the first few minutes today kind of reviewing what we've been doing for the past, I guess, 3 weeks. Um, starting, so if this is our MVC, the most recent lectures were really focused on the models. We want to extend the models to be able to use and store data more complex than just the classical like list that you have at the top of your app. So last lecture given by Reed was using user defaults and other systems to actually store that data on your phone, retrieve it, and implement like updates to the view and whatnot. And the other thing that we've kind of touched upon that we're going to be focusing on more today and on Wednesday is HTTP requests. So storing data on a cloud, allowing your app to communicate to other apps via a central like storage system in some basement somewhere. And to be more specific about that, we use HTTP requests. So this is your app. That's your server or database. We like to request data from this. So a good example, if we're building something like eateries, you want to know what the eateries are, the times, we would use an HTTP request to communicate with our database system. And the API and database, if you want to learn more about that, that's our intro to backend course. And also this is useful for when we do the hack challenge because this is how you actually collaborate with your other team members, like the backend course and all that. So to make an HTTP request, we have to define a few things. The first is the URL. We need to say, what is the location of our server? How do we access it? That's the URL. And then we need to pass in different, I guess, parameters to specify what it is that we're requesting. So the first might be like parameters. That could be stuff like search queries. If you ever type in Google, you can see there's like a little question mark and then a search equals. That search equals is your parameters. And the URL is Google. You need to say the method. So in this course, we really only use get, post, and delete. You notice that kind of coincides with our CRUD model, right? Create, you want to post data to the server. To read, you want to get data from the server. Update, you're also posting, and then deleting, you delete. And then we also have other methods of sending data to the server. That could be stuff like headers. Headers are usually used for a little bit bigger data, things like authentication tokens, things like the way you want to receive data in response. And then things like an actual body. Like let's say I'm sending a paragraph or like information about my app. I send that to the server. And then the server will respond with three notable things. The first being the response code. 200 is successful. And then as we've covered before, like 400 is an error. The actual data, which comes in the form of JSON, and then an error if there is an error, but hopefully there is not. I think the way it usually goes is if the response code is 200, there's a value in data. If the response code is an error code like 404, you get a value in error. Cool. So to kind of demo this more, I think Elvis made an announcement to download Postman. If you don't have it downloaded now, don't worry about it. We don't particularly need it for this demo, but you will need it in the future. Postman provides us with this lovely collection of, I guess, random databases and random servers out there. So there's a whole list of a lot of databases. I'm going to use cars in this demo, specifically make cars. You can see it provides us with this nice URL. This is the URL of the database that stores a whole bunch of different types of cars. And what Postman allows us to do is make fake HTTP requests to, I guess, ping different servers and test that out. So if you downloaded Postman and would like to follow along, that's great. If not, don't worry about it. This is the main interface. We start in collections, so ignore the previously existing ones, but each collection is generally like an app or a single database that you want to use. So I'll make a new collection and I'll name it networking demo. And then in this networking demo, if I expand it, you can see there's an add request. I can also just press this plus button up here, but I'm going to press add request and I get a new request. This is just a filler for a blank HTTP request. We have a place to put in our URL, a place to specify what type of request it is. We have our parameters, headers, body, everything. So just as an example, I'm going to take this random database about car makes, and I'm going to copy the URL. I'm going to just copy it and paste it in this URL. You'll see that Postman is pretty smart, and it noticed this after this. Can everybody see this, or is that too small? Okay. It has this little question mark here, and after the question mark is where all of our parameters are, right? Like the Google search thing. In this case, we have one parameter, format equals JSON, and that's just stored in our parameters tab as a key value pair. And I can like change this to whatever I want, and you'll see it'll update the actual URL on the spot. But I'm going to keep this as JSON. We want it to be a GET request because as defined in our specification, this is a GET request. And then if I send the request, we get a response. You can see we have a 200 response. That means it was successful. You can see other information about it, which you won't necessarily need. But the important stuff is the actual response. So this part down here, this is what gets returned to you. Out of the three things, we have our response code and we have our actual data. This data in the form of JSON represents a whole bunch of cars and their different makes. So we have the number of cars, a response code, and then a list of different car IDs, I guess. Nice. Just for demonstration, if I took this like key value pair, put some random stuff in here and press send, I will get a failed request, or I won't get a failed request. I'll get nothing because it's in the parameters. But, oh, yeah, sorry, that's not what I meant to do. This format basically specifies that we want it returned in the JSON format, right? If I tamper with this, as I just did, or I get rid of it altogether, this specific API defaults to sending it to us in XML. And we don't like XML. So if there's ever XML, we always want to switch it to JSON, either through the parameters or through the headers. But if I tamper with the actual URL, right, if I say get all makes ASDF, that probably doesn't exist, probably not implemented. And for that reason, we have a 404 error, not found. Yeah. The last thing, this is a URL. So just like any browser goes to any URL, I can just paste it in my browser and see what comes up. And you'll see it actually just returns the JSON in my browser. So I can view it here, which is not fun to view it, or I can view it in this like pretty printed format. Nice, like that. Cool. So does anyone have any questions on Postman as like a little demo? So as you're working on, I guess, the project, and as you're working with backend developers, you'll get like a specification for the different endpoints for an API, and it's useful to just test everything out. And this is kind of documentation software for documenting your database. But now that we've tested it out, know that our database works, see that we get response, how do we actually handle that in Swift? So there's kind of three parts that I want to go into. The first, once we get our JSON data, how do we actually handle it? How do we process it into a model? And for that, we use JSON decoding. The second is how is information passed around, right? Let's say we got our JSON data, we've processed it, it's now safely in a model, stored in an object somewhere. how are we going to pass it like from the URL request to our model or from our model to our controller? For that, I'm going to get into closures. And then lastly is how do I actually implement the HTTP request? How do I actually connect my app to the internet? So I'm going to go through these one at a time, starting with JSON decoding. By the way, if you get a malformed JSON, that's probably not your fault. That's probably the backend's fault. Just throwing it out there. So on the right, you'll see this is the actual exact JSON from the URL that I got. It's just formatted nicely here. Every JSON either has objects, which are key value pairs, or lists of objects or values. So in this case, you can kind of see we have this set of key value pairs, make ID, make name corresponding to an integer, and then a string with the make name. This little thing, that's one object. This is like a list of that object. And then this entire JSON thing is a parent object that stores another key value pair, one of the values being a list of other objects. So when dealing with JSON, you kind of get this like object hierarchy. And when we decode it, we want to mirror this hierarchy using objects in Swift instead of in JavaScript. So to do that, every object is a struct. And my personal recommendation is to start with the smallest object and build upwards. So in this case, when I say smallest, I mean like the farthest nested, the one that doesn't have any objects inside of it. So in this case, this is the smallest object. It just has values like integers and strings, no other sub objects. And to process it, we make like a one-to-one mapping of a struct. Yeah, so you'll see the actual, I guess, key is exactly matching the name of the variable. And the value is exactly matching the value that we want. So this is an object, this is a car make. And then if we wanted, we make the full object, which has as its results a value of a list of these other objects. So this is kind of the translation of how we would store that in a Swift object syntax. And then you'll notice that we have this codable stuff here. These structs are all codables because Swift actually provides us this fancy functionality where we can just say, this is a one-to-one mapping of our JSON to our objects in Swift. We can just call our Swift's function, which is called the decoder, and plug it into the objects on the spot. So this chunk of code here would be like after you do your networking, after you get a data value, we set let data equal whatever value is returned from the network. All we have to do is make a JSON decoder and basically tell the decoder to like stick it in this object. To be more detailed about it, we have decoder.decode. We pass in all cars.self. You remember all cars is just the entire object. And then from the data that we want. You'll also notice that there's a try with a question mark here. That's because a lot of times, if your JSON doesn't exactly match your struct the way that you've defined it, this decoding system won't work and it'll crash on you, which is why we have that safety if let optional system there. But if it does work, like in this case, it should succeed. And we should, by the end of this if let statement, have a new variable decoded data, which I can access the properties just like I would this JSON. Does anyone have any questions on this at the moment? Yes. Because try returns an optional. Yeah. So yeah, you can see this try has a question mark there, right? Like that's just saying that we try it optionally. I could put an exclamation point after the try and then not have to do this whole thing, but then if something is wrong, it just crashes. It's like force unwrapping. Yes. So the codable is it's actually a protocol. But the way that we implement it is we just say that all of our classes that will be parsed are of type codable. So you can see this all cars is a class of all cars that is also a codable object. That's kind of what the colon means. If anyone's taken, I think 2110, this is the same as like class hierarchies or interfaces. But yeah, it's just labeling our class as something that can be decoded by a JSON object. Yes.
So basically the all cars struct, we're making that would be based on whatever JSON we're taking.
Yes.
It has to match.
Yes. Yeah. So that's a big point, which I'm going to actually get into, is that things to note, the variable names and data types must match. This is something that I can't emphasize enough, because last semester we had people like debugging their code for hours, couldn't figure out what it was. And then it turned out that it was like, haha, they accidentally lowercase the capital thing. So make sure that your variable names exactly match the key values here, and that the values are exactly the values there. And then if not, you should get an error that's like cannot parse JSON something. So that's one thing to note. The second thing to note is to include necessary optionals in your decoding. So you'll actually see in this example, I have this key value pair search criteria, which is of value null, which is the same as nil. So to properly parse that, my search criteria variable has to be an optional. If I didn't make that an optional, the decoder would get mad at me and be like, this value is null. I can't set a null to a string, so it gets mad. There's that. You can also use optionals to declare variables that might not exist in the JSON, right? So I can add like a fifth variable to all cars and be like, var extra variable is an optional int. And if it's not there, it'll still parse correctly. And that value just gets set to nil. And then the last thing to note is to make your structs codable. Just allows the JSON decoder to go in there and basically stuff your objects with the correct data. Cool. Now closures. Yay. Closures are kind of an inherently like weird thing to understand. So I'm going to try to go through this slowly. And if anyone has any questions at any point, feel free to ask. But before we get into specifically closures, we're going to take a step back and introduce the concept of using functions as variables. So I made this function here that's called print string 5 times that takes in a string named str, loops 5 times and prints it out, right? I can call this function with a string and it'll print the console 5 times. So when I want to use it, I can do this fancy thing, making a variable equal to the function name. And then this variable is now the function. So if you see let a equal this, we don't have the parentheses. That means that a is of an equal type as print string 5 times. So the same way that I'm actually calling this function with a string, I can now call a with the string as well. And if I go into Swift's natural documentation and click on a, ask what type of variable is a, we have in the top right, a is of type, and then those, I guess, parens and arrow means it's a function that takes in a string and returns nothing, which it is. It takes in a string and just prints it out, doesn't return anything. And we can call a with any string. Now, if we can store functions as a variable, we can also pass in functions as a parameter to other functions. So what that would look like, I have my function print string 5 times. I'm going to make another function called input a function that takes in a parameter of type a function that inputs a string and outputs nothing. And then all my input function does is call that other function. So the example of a use case is I let a, my variable, be equal to this function. I pass this function into my input a function, and then it gets called with the hello world, and it prints 5 times. So yeah, I guess to go into it more, this my function parameter takes on the value of a, which is equal to this function, And then when you call it, you're just calling A, which calls this function 5 times. Cool. Does everyone understand up to this point? Or any questions, I guess? So then the other thing, which is closures, is I don't actually have to make a function and store it as a variable and send it in. I can define it on the spot. So I've just deleted my print 5 times function altogether. And I make this function, which inputs a function. And instead of like making a separate function and passing it in, I've fully defined the function that I want to pass in, like in line, in the actual line that I'm calling this function. So this is kind of another way to declare functions where it's like an anonymous, it's technically called an anonymous function. It takes in a set of parameters. It has a return type, and you say in, and then whatever you want the function to do. So in this here, between these two curly braces is a whole entire function that takes in a variable that I call my parameters, and it prints it once to the console. Now, because input a function has this parameter, my function, that takes in a string and outputs void, this function is that. So we know that my parameter will be of type string, because that's the input, returns void, and then it just prints it to the console. So my function takes on the type of this function, which gets called with hello world, and it prints to the console. Yes. Like, do you mean down here? That's me actually calling the function. So this is like, I call the function and then I pass in my parameter, which is supposed to be a function, as just that function that's defined right there. So like, yeah, functions don't have instances. Classes and objects have instances, but it's kind of the same thing where I'm actually like calling the function and using it. Does anyone have any other questions on closures? Yes.
So you're defining like my parameter inside that all. You didn't define them.
Yeah. So this here is a definition. I'm gonna kind of switch back and forth. If you see this function print string 5 times, has this parameter string, which is like defining a new variable within this function of type string, and it gets used within this function. The same way we define this like string as a new variable that takes on the value that is whatever passed into it at this point is a string. We do the same thing here, where this is the new variable that we're defining. So my parameter is equal to this str variable in this example. This is our new variable that takes on whatever value is passed into this function. So when we're actually calling this function, which is when we call my function, because my function is equal to this, we call it, we set this string equal to my parameter. And then my parameter gets printed to the console, which is just hello world. Cool. Does anyone have any other questions? Okay, then we will go on to how to actually implement HTTP requests. So I kind of like to think about HTTP requests in 3 parts. We have the URL request, or sorry, we have the URL, which is the location. We have the URL request, which has everything that's needed to actually request data. And then we have the system that actually calls it and sends it over the web to request data. So the first part is this URL. You can see we just make a simple object, variable URL is equal to this string, our URL. This is actually the same URL that we've used in our example over here, right? The car. And we have these parameters that we want to input. To input these parameters, we can do the same thing. We can actually just copy them as like a question mark, something, something, and set it equal to here. But to kind of keep it neat, we like to separate it out as let format parameters equal a UI query item, which just represents one set of parameters, and then we add it to the URL. This is analogous in Postman to like putting this key value pair down here, and then Postman does the work for you, like sticking it on the end of the URL. That's the same thing here. We just say we want this key value pair, and then Swift does the work and just sticks it on the end of the URL there. So that's our URL. Just specifies the location and some extra data. On top of the URL, we have the URL request. Again, this is where we specify things like, well, first we pass in the URL from our previously defined URL. We specify what method it is, so get, post, or delete. And then we can add other values such as headers or data or whatever we want. This URL request object, I would say represents like this entire like view up here. So this represents the URL, represents parameters, it represents your headers, your body, your authentication, if you deal with that. Most of the stuff we don't actually deal with in the class. The only thing is really parameters and headers. And for that, we just set our value for headers, just like a key value pair down here. And then once we have our URL request, we just need something to actually send it over the internet and make this request actually happen. And to do that, we have URL sessions. So we have, what we do with this session is we basically say, we're going to make a task, which is again, just us sending our request over the internet. URL session.shared.task. We specify the request that we want to send over the internet. Again, the one that we just defined. And then we have a completion handler, which you'll note is a closure. And then we just call resume. So we define the task here, and then this task.resume actually executes it and like sends it over the web and gives us our response. So this is basically the setting up of the networking call. Does anyone have any questions on like any of this code on this screen? Okay, so once we've made a request, we've made a session and a task to actually execute this request. When we get data, how do we actually handle it? You'll notice in our URL session, we have our nice closure here. This task takes in a function that has the three sets of data, right? Our data, our response, and our error. And the whole point of this is basically it wants you to define a function. So it wants you to make a function that does whatever you need to do with your data, your response, or your error. And then you're supposed to pass your function in so that when it's done like pulling data from the internet, it can defer back to your code to see what to actually do with that data. So again, we have our three values here. Then implemented this as a closure, you'll see the first line is exactly the same. We have URL session.shared.data task with our URL request, but now we've set this closure up as a function. So between these two braces is our function that we define, our function, that takes in three parameters, the data, the response, and the error. And we get to handle it however we want. So you'll notice that the data, all three of these are optionals because a request might or might not respond with a value. And then we can just process them as we want. So we check if our response can be handled as a HTTP URL response. And if it can, then we know that we can pull out the status code. That's the thing that's like, is it 200 or 404? If we do, if our data exists, if let data equal data, then that's exactly where we kind of started with the JSON stuff. When I said we'll let data equal something eventually, this is the data. So from here, we have our data and we can just pump it in our JSON decoder, which will fill like a struct with this data returned from the internet. And then we have our error, which hopefully doesn't exist, but if it does, this statement will print out. And then lastly, we have our task.resume, which kind of starts everything, and then this just gets called whenever the data gets returned. Yes.
The web variable response line should always print.
Should always print.
Yeah, because you would always get the response code, right?
Yes. So you should always get a response code. The printing is just like for our sanity check to make sure that it's 200.
So if the JSON object were empty,
Mm.
would the if let data equals data would that work?
If it's like an empty JSON object, then it would. If it's just empty as in like no value, then it wouldn't. Yeah, and I guess kind of to go off that, this whole response stuff in this example, I've kind of just printed it to the console, being like, tell me what the response code is. You can use this for handling responses the way you want to. So I can say like, if response is 200, I can send a message to the user being like, you successfully pulled data, although I don't know why you'd want to send a message. If response is like 400 something, you can put a message just like, there was no internet connection. But you can switch on this status code to tell you what to do. And then, yeah, another thing in this actual data, if the data exists, if there's something returned, in this demo, I've just printed it out as a string. You'll see I have string data is data, and then I've encoded the UTF-8 encoding. You don't really need to know what that means, but it's a way of encoding data into strings or strings into data and vice versa. That line can just be helpful if you want to see what's being returned from the internet, like verify with your own eyes that it is what you want it to be. And then, yeah, if you do get an error, it's nice to print it out. Yes.
Like, for example, this one, when you try to like use the task variable.
So it's a good question. We define the task variable with this as that whole thing. And nothing happens until we do task.resume. So task.resume is like the way of telling this URL session to like go on the internet and like actually make this request happen. Before that, we're just defining it. We're saying this is a task that's to be done. Task.resume like makes it do. And then this function, this closure that we define and pass into our task gets called whenever that data is returned from the internet. So that's kind of the system. So kind of putting it all together, we have the 3 sections that are important for networking. The first is defining the URL. The next is making a URL request with this URL and all of the parameters and whatnot. And then the last, or I guess the last 2, are making the session and then handling the response. Yeah, so this is like a huge chunk of code. I guess this chunk of code can go anywhere where you want to like pull data from the internet. So when I was making this demo, I just put it in the main view did load. And then whenever I ran the app, as soon as the view loaded, it called data from the internet and just printed out all of the cars in the thing. But on Wednesday, I think Elvis will go into more how to keep this networking data neat and like in a separate isolated class that we can use with our model and communicate back and forth. Does anyone have any questions on this whole networking system as it is? Okay, there's one last thing that I want to get into that I guess was kind of briefly touched upon, which is multi-threading. This isn't something that you particularly need to know about, but it's nice to have it in the back of your mind to understand. So when we run code most of the time, you'll see everything happens in like a sequential order, right? But the internet is slow. So if I want to pull something from the internet, I send a request. I don't know how long it's going to take to get back. It might never get back if I have no internet. And so the way that this all gets handled is through multi-threading. And what that basically means is that everything is run sequentially up to task.resume. And once I say task.resume, everything continues to run sequentially. And I would think of each like sequential running as a single thread. But then because we have to wait for this networking stuff to happen, we are basically waiting on a separate like sequential code running thing. So our app will continue to run normally, and this function will basically get called whenever the internet feels like responding to us. So if you have really fast internet, this function will happen like almost instantly. If you have really slow internet, it might take a while. That's why if you like dealing with, I don't know, like a social media app, for example, let's say you pull up Instagram, I can switch the pages that I'm viewing on Instagram before any of the actual data loads. That's because they're happening on two threads, right? The code responsible for me dealing with the app is like running at the same time that the code that's requesting data from the internet is running. This is not something you particularly have to know or know how to handle. It's just kind of nice to think about in the back of your mind, and it can be a place where errors occur, but hopefully they shouldn't. I guess Elvis will get more into that on Wednesday for the things that we actually need from that. But yeah, other than that, does anyone have any questions? Cool. Then I think we go on to the code.